Okay, we're going to be starting arc length and sector area for this week. And I just want to kind of go over some of these with you. Let's go ahead and look. Okay, here's some just of the vocabulary that you're going to need to know. Okay, most of these are review. Most of these you should have heard before or should know what they mean. A circle, the shape of it is just any all points are equidistant to the center point. We went over that towards the beginning of the semester. The diameter is all the way across, going straight through the middle of the circle. The radius is only halfway. A central angle is anything that has that starts at the middle of the circle. So like AC, this part right here, this angle APC, that would be a central angle. If it were to have another line coming from B here and going this way, that wouldn't be a central angle because the angle starts on the outer circle. That's some of the stuff that we went over last week. Okay, some other things is that congruent circles, they have to have the same radius. So as long as the radius are congruent, the circles are the same size. Okay, right here, some of the formulas that you should already know about circles is for the circumference and area. Circumference is right here. You can have either one of these are the same basically, since the radius, 2 of the radius equals the diameter, you can write it either way. If you have the diameter, just multiply it by pi. If you have the radius, double it and then multiply it by pi, and that's the circumference. That's just going around the outside of the circle, the distance. So right here is just using this technique. I would just plug in pi. You should be able to put that in your calculator so that your answers are more accurate. Okay, so if you're looking here, all circles, no matter what kind of circle they are, they have to be similar because unlike other shapes, there are no sides. It's just so everything similar just means that it's the same exact shape. It can be different sizes. So you can't draw a circle any other way. A circle is a circle. We're not talking about ovals here. Ovals don't have to be similar, but circles would. The dilation is just saying by how much bigger is it. And we did that when we were doing before break, we talked a little bit about that with dilation and everything. Concentric circles just means that they have the same center. So right here, these two circles, the smaller one and the larger one, are concentric circles because they both have the same center. Those are just vocabulary terms that you're going to need to know. You might see them here and there. Okay, this is where we're mostly getting to what you're going to be having to figure out. And sometimes we know how to solve for the entire circumference, but sometimes you need to only solve for a part of the circumference, not the entire thing. So this is a formula, and here it looks a little more complicated. I think on the worksheet, it simplifies it a little bit, and I'll explain how it relates to the sheet in a minute. But basically, if you plug it in and you know the radius and you know the measure of an angle, then basically you can figure this out. You can figure out exactly what the arc length is. How long is AB? If you have this right here, this degrees, the degrees and the radius, you have enough to solve it. And on the worksheet, the only difference is it has it over 180, but then it got rid of this 2 because if you divide 360 divided by 2 and you get rid of that, then this would be 180. So it's the exact same thing on the worksheet. I think it's worksheet number 2 or that it has that at the top of the worksheet, this formula. And they're basically the same thing. So let's look at some examples of this. Right here, this would be, for example, if I had a circle and the central angle is 50 and the radius is 5. If I had something that looked like that, that would be what I'm solving on the first one. And you can try it on your calculator. You can kind of get used to plugging it in. All you would do is you would take the 50 times 5 times pi and divide it by 180. Or you can do what it says there, and you're going to get the exact same thing. You can multiply all of this times 2. All of these, you're multiplying all these 4 numbers and then dividing it by 360. You'll see that you'll get the exact same answer no matter what. And so that's all they're doing to figure these out. They're taking those 2 numbers and they're plugging it in. Now, there isn't any like this on this worksheet, but you do need to know how to do this. If they give me, for example, an arc length, let's say I have a picture here and I want to figure out the angle, but they gave me that this is 13 inches and this is, I don't know, 10. I don't even know if that's going to be accurate. What you would do is, if you want to figure out what this angle is, you would plug in everything just like you would do it. So you would put theta instead of the 50 times pi times 10 theta, let's see, the angle, and then divide that by 180, and that equals 13. So now if you look, this would be your, this is basically the variable that you're solving for. So what you would do is you would, just like we did in algebra, you would get this variable by itself. You would multiply by 180, that gets rid of that, and then you would divide by these two. You would divide by 10 pi, and whatever that answer is, that would be whatever the degree angle is that you're looking at. Okay, that's just a side note. Let's go ahead and keep going. That a sector is not just the outside length of an arc. The sector is, let's take that entire arc down to the center, and that's an entire area, not the area of the entire circle, but of a piece of it. And this is the, right here, this right here is the formula for that. It's also on the worksheet. And you just take whatever the radius is and square it. You multiply it by pi and whatever the angle is, and then you divide it by 360. So that's basically what you're doing there. That should be the same on the worksheet, I believe. Let's look at an example. Let me make this a little smaller. Okay, so if I have, for example, this would be a circle with it says that it has a radius of 15 and 72-degree angle. If I wanted to know not just this piece, I wanted to know the entire thing. Well, basically what I'm doing is I would have to, on the worksheet, it has you solve for this, and then it multiplies it in. Okay, so you have the difference here with this, the reason that this one looks different is because on the worksheet it breaks it up into two. They have you find theta, whatever the angle is, times pi r, divided by 180. That's what it says on the worksheet. And this tells you what the sector is. And then to find the sector, they do basically all of this sector times r divided by 2. So basically this would be the same thing. You would have the sector, this is where you're getting this is where they're getting the pi r squared. And then 180 times 2 would be 360. So basically it's if you were to just do these instead of doing it into 2 steps, you do it in 1 step, you would basically have the same you'd basically have the exact same equation that's right here. You would have whatever the angle is times pi r squared, which is the area of the circle, and then divide that by 360. So you're basically taking the area of the circle and multiplying it by the fraction of the circle that you're figuring out. What they did here, it's important when you're putting this into a calculator that you use parentheses or you do it in parts. Multiply everything and then push enter and then divide everything, and that'll make room for less mistakes. Let me see. Okay, so if you're looking on the first worksheet, let me see, I think we're done with that. On the first worksheet, one thing that I just want to add before I close is that you're just using your basic formulas on the first assignment. So you're just using circumference equals 2 pi r, or oops, pi times the diameter, or you're using the area equals pi r squared. You're basically just using those, and you just need to know your vocab terms. What is the radius? What is the diameter? And so that you can actually solve those. But if you have any questions or you need any help, feel free to contact me. I've given out my phone number to a lot of people. If you message me on the site or you email me, I will get back to you as soon as possible. I'm here to help. Take advantage of that. And good luck.